In this chapter, acid, bases and salts, let us learn the remaining teaching points of this lesson. We already learned what is acid, what is a base, their properties, how they react with different metals, water and other chemicals. We discussed already about the indicators, the types of indicators and many other points. So let us see what do all acids and all bases have in common. Glucose and alcohol solutions do not conduct electricity. Hydrochloric acid, sulfuric acid, sodium hydroxide conduct electricity. There is an experiment in your textbook in which we are taking a beaker carrying a rubber cork with two nails, and it is connected to a battery with a key. And when you take in this beaker the solution of hydrochloric acid, what happens is, as we know, acids will ionize. When you pass the current, they will ionize into H plus ions and Cl minus, cations and anions. Okay, so sulfuric acid if you take also, the same thing will happen. Sodium hydroxide if you take also, the same thing will happen. But if you take glucose and alcohol, although they contain the hydrogen atom in them, but they will not conduct electricity. So this is a very important point, that all substances which are containing hydrogen is not an acid, so they will not conduct also. So properties of the acids and bases may differ. Okay, so that you have to keep it in mind. And how they dissociate, we already know. If you take different acids, how they dissociate. But remember, glucose and alcohol, they don't dissociate. They don't give H plus and OH minus ions, and because of that the bulb in the experiment will not glow. So that you have to keep it in mind. And then here you can see that this is the experiment which I was talking about. The acid solution in water conduct electricity. You can see there a beaker, a rubber cork, a bulb, a 6-volt battery, beaker, and they have taken dilute hydrochloric acid. Yes, so they have taken this. We have to repeat the experiment with the different acids. Then we have to finally use glucose and alcohol in them, and we have to see whether the bulb will glow or not. Okay, so the electric current is carried through the acidic solution and basic solutions by ions. So ions are responsible for the conductors. Okay, so the bulb glows, and this will help in conduction. So that point you have to keep it in mind. In glucose, the solution, and alcohol solution, there are no ions, so conduction will not take place. So there is no ions, they will not give the ions, therefore it will not conduct. So this point also we have to keep it in mind. What do all acids and bases have in common? Acids contain Cl minus, NO3 minus, SO4 2 minus, CH3CO minus anions. That's one part of it. Then acids produce H plus ions, cation, in the solution, which are responsible for the acidic properties. All bases have OH minus and hydroxyl ions in common in them, that is in the bases. Bases produce OH minus ions in the solution, which are responsible for the basic properties of the chemicals. Next, let us see what happens when the acid or base react with water. Acids produce H plus ions in the presence of water, whereas bases will dissolve in water to give OH minus ions. H plus ions cannot be exist alone. They exist as hydronium ion, H3O plus. H plus H2O gives H3O plus. Hydronium ion In the presence of water, the bases will give cation and anion, Na plus and OH minus if you take the sodium hydroxide. If you take magnesium hydroxide, Mg2 plus and OH 2 minus. Okay, fine. Next, so we can write the equation as HCl plus H2O gives H3O plus Cl minus. Bases are soluble in water are called as alkali. The water soluble bases are called as alkalis. So this point also we have to keep it in mind. Water to acid or acid to water. How to add acid to water or water to acid? Which is the correct procedure is a question. Always add acid to water. So we should not add water to acid. Why? Because it is an endothermic reaction. Now, the heat will be liberated, and there will be a may fire accidents may take place, or the burn the skin or hand may burn. So the problems will be there. So that's why we should not add water to acid. We have to add acid to water. So that point is very, very important. So please keep it in mind. The acid must always be added to slowly to with the water with constant stirring. You have to take a rod and you have to stir it properly. Next, the process of dissolving an acid or a base in water is highly exothermic reaction. Exothermic means the reaction in which the heat is liberated. So adding the water to acid or base leads to the cause of mixture to splash out. Yes, that's what it happens. Break the glass container also. It may break the glass container. So what happens when we mix acid or base in water? Mixing an acid or base with water results in a decrease in the concentration of ions, hydronium ions per unit volume. Such is called as dilution. This process is called as dilution, and the acid or the base is said to be diluted. The strength of an acid and base. The strength of an acid or base can be estimated using universal indicators, which you already know now, different types of indicators. So what are universal indicators? Universal indicators is a mixture of several indicators. It shows different colors at different concentrations of H plus ions in the solution. Then, to find out the strength of the acid or base, we use a pH scale. A scale of measuring hydronium ions concentration in a solution is called as pH scale, where pH stands for the potens, a German word which means power. On the pH scale, we can measure the pH generally from the 0 to 14. There are 14 numbers, 0 to 14. So if you take 0, it is very acidic. If you take the last one, 14, it is very alkaline or basic, we can say. The middle number is 7, it is a neutral one. So from this, if it comes 7, then it is neutral. It is there in the book along with the picture. So you can see their trend. 7 means neutral. If it goes towards 0, it is acidic property will increase, and 0 it is maximum acidic property. Basic also, if it goes till 14, same, the basic concentration will be more. On dilution of acid, pH increases. On dilution of base, pH decreases. So this point you have to keep it in mind. There is one activity that is in the book that test the pH values of the solutions given below. So I already mentioned the values there. The gastric juice is 1.5 to 2. It is in, then the lemon juice, orange, saliva, blood, water, milk of magnesia and sodium hydroxide, different values. So this is a table, and their properties also are mentioned. The importance of pH in daily life. The plants and animals are pH sensitives. As we know, for the growth of the plant, they need this value of pH. Otherwise, the soil, what we say, will not be helpful for the plants to grow. The animals also, they are pH sensitives. Our body works on the pH value from 7 to 7.8. When the pH of the rainwater is less than 5.6, it is called as acid rain. As we know, what is acid rain and how it will cause the problems for animals and aquatic plants and animals, and also the generally. The pH in the soil, the plants require a specific value of pH and the range for their healthy growth. So the plants also require pH for their healthy growth. So we have to see the soil should not be too acidic or basic. Then what happens is it will not help in the growth of the plants. So the pH value, that's why we add calcium oxide, calcium hydroxide, calcium carbonate, so that it will neutralize the acid which is present in the soil. So that we have to keep it in mind, the values. The pH changes as a cause of tooth decay. Yes. So as we know, the enamel which is there in the teeth, will be damaged and it will cause what you call cavity there. And if the pH value of the teeth is less than 5.6, some particular value, then what happens is it will cause tooth decay. The value 5.5, yes. So tooth decay starts when the pH value of the mouth is lower than 5.5. So what we do is, whatever food is remaining in our, maybe the sugar filled items or anything, whatever the remainings, they will react with the bacteria which is present in the mouth and may lead to the some chemicals which will cause the tooth decay. So therefore we have to use how to minimize this by using a paste which is basic in nature, so that the value of pH of the mouth should be maintained with the proper value above 5.5, not lower than that. Tooth enamel, made up of the calcium phosphate, hardest substance of the body, does not dissolve in water but corrode the pH lower than 5.5 due to the acid produced by the degradation of the food particles by bacteria. Just now I told you the point. Using the toothpaste, which is basic in nature, we can prevent the tooth decay. pH in our digestive system. As we know, our intestine will produce hydrochloric acid, which is helpful in digestion. Our stomach produces the HCl acid, which helps in digestion. During the indigestion, the stomach produces the more acid that causes the pain and irritation. To get rid of this pain, people use antacid like milk of magnesia to neutralize the excess acid. Self-defense by the animals and plants through chemical warfare. Bee sting leaves an acid which causes the pain and irritation. Use of a mild base like baking soda, spelling is wrong there, so it should be soda, SODA, on stung area gives a relief. So how we can neutralize if we get the pain by the bite of the stings? The sting hair of nettle leaves inject the methanoic acid causing the burning pain. Rubbing with the leaf of dock plant gives a relief. The dock plant is a basic in nature, so it will give some basic chemicals maybe. So because of that, it will relieve. Chemicals in common salt. Sodium hydroxide, bleaching powders, baking soda and washing soda. These are the main salts. Now we are going to see about salts and their production and the uses. The sodium hydroxide, calcium oxychloride, sodium hydrogen carbonate is called as baking soda, and washing soda, sodium carbonate decahydrate. So let us see what is sodium hydroxide will do. So these are the different salts. Sodium hydroxide is called as NaOH, which is produced in this method of taking the brine solution in a big container with two electrodes. One is titanium electrode and mild cathode steel electrode, and using a brine solution. Production is done by a process called as chloroalkali process. When the electricity is passed through an aqueous solution of sodium chloride, it decomposes to form sodium hydroxide. NaCl plus H2O gives NaOH plus Cl2 plus H2. H2, sorry, H2 is the gas. The uses of sodium hydroxide, it is used as fuels, as hydrogen in fuels and margarine. Chlorine is also relevant. It's used in PVC and CFC, which we know. Hydrochloric HCl, preparation of HCl, cleaning steels and medicines. So it is sodium hydroxide and decreasing the metal soaps with the and paper making. So the bleaching item also, house bleaches and bleaching fabrics. Next one is bleaching powder, calcium oxychloride. Production is done. It is produced by the action of chlorine with the dry slacked lime. Cl2 plus CaOH twice gives CaOCl2 plus H2O. This is the method of preparing bleaching powder. The uses, it is used in bleaching powder is used in cotton and linen textile industries. It is used in wood pulp in paper factories, oxidizing agent in chemical industries, and disinfecting in drinking water. Next one is baking soda. Baking soda is also called as sodium hydrogen carbonate, which is produced by using a sodium chloride as one of the raw material. So NaCl plus H2O plus CO2 plus NH3 gives NH4Cl plus NaHCO3. Ammonium chloride and sodium hydrogen carbonate will get as a product. The uses are for making the baking powder, which we know, which is used in bakery items. When baking powder is heated on or mixed with water, it produces carbon dioxide, which causes the bread and cake to rise, making them softy and spongy. And ingredient in antacid. Antacid we know. For acidity we give that chemical like ENO and other chemicals. Used as a soda acids and fire in fire extinguishing items. Washing soda, the production of washing soda, that is sodium hydrogen carbonate, the last chemical, is used by is produced by crystallization process of sodium carbonate gives a washing soda. So Na2CO3 plus 10H2O gives Na2CO3 dot 10H2O. The uses of this washing soda are: it is used in glass and soap and paper industry. It is used in preparation of borax glass. It is used in cleaning agent for domestic purposes, for removing the permanent hardness of the water. So this is just for your question. What is 10H2O? It's called decahydrate water molecule, 10 molecules of water. So are the crystals of the salt really dry? Let us understand it using a copper sulphate salt. So if you take a copper sulphate salt in a test tube and if you just heat it, then what happens? The copper sulphate crystals, which seems to be dry containing water of crystallization, when we heat the crystals, this water is removed and the salt turns white. If you want the reaction, then it is CuSO4 dot 5H2O gives CuSO4 plus 5H2O. If you moisten the crystals of again with the water, again if you put little water, you find that the blue color of the crystals reappears. You can observe here. Water of crystallization is fixed number of water molecules present in one of the formula of unit of a salt. This point please keep it in mind. Examples of salts which have water of crystallization: copper sulfate, washing soda, gypsum. So all they contain five molecules of water, 10 molecules of water, 2 molecules of water in different amounts. What happens if we heat gypsum? That we know that gypsum is nothing but the plaster of Paris, CaSO4 dot 2H2O. If you heat, you get CaSO4 dot half H2O plus 1.5 molecules of water. This is also called as plaster of Paris, which is used as a decorative items. It is also used in for the preparation of plasters in medical industry. So what is plaster of Paris? The plaster of Paris is nothing but calcium sulphate hemihydrate CaSO4 dot half H2O. It's called as plaster of Paris. How to produce this plaster of Paris? On heating the gypsum. Gypsum is calcium sulphate dot 2H2O, the two molecules of water. At 373 Kelvin, if you heat, it loses the water molecule and becomes the plaster of Paris. Okay, so from 2 it will becomes half molecules of water. If you write the reaction now, CaSO4.2H2O gives CaSO4 dot half H2O plus 1.5 molecules of water. Uses, it is used by doctors to use the pop for support for the fracturing of the bone. Then it is used as is used in toys, materials for decoration, for making the surface smooth. What we call that, false ceilings. Heating the gypsum gives a POP, plaster of Paris, and adding the water, plaster of Paris will give gypsum. So it's just a vice versa reaction. We have to keep it in.